When you look into the sky, there are white stars, all shades of blue, red, yellow, orange, and even brown and black given the right circumstances. So with so many possibilities, why does it stop there? Well, the reason isn't that the stars have limits, it's the limits of the human eyeball. People aren't wired to see colors outside of certain frequencies. This range of frequency is called the visual spectrum, which covers less than 0.0035% of the electromagnetic spectrum. Here you can see the visual spectrum, and here you can see the entire electromagnetic spectrum. Because of the way human eyes prioritize color, we are unable to see certain colors, and there are colors that our eyes automatically focus on even if there are other colors mixed in them, such as blue, yellow, or red. Our own sun from space is actually a white color, however from Earth it looks yellow or orange. This is because what we are seeing when we look at a star isn't a single color, but a result of multiple colors mixing together. To see which colors a star is giving off, we can look at its blackbody curve. A blackbody curve is a graph of all the frequencies the star is producing. Since every color on the visual spectrum has a frequency, the star's blackbody curve can be used to identify what range of colors are being produced by it. Surprisingly enough, our sun peaks in its green frequencies. If we were to see the sun's true color, it would be green. But there is more to color than meets the eye. A lot more. Sunlight meets the Earth's surface as a yellowish or white color. Its blue light frequencies are absorbed by the atmosphere, making the sky blue during the day. At certain times in the early morning or late afternoon, it can look orange, just like the light that hits the surface. Just like the atmosphere separates the blue and red light, the sun's green light can be separated using an object called a dispersive prism, like the one seen here. Sometimes this diversive lighting effect can happen naturally, and you have likely seen it dozens of times if you've ever seen a rainbow. What we can conclude from this is that the color green is in sunlight, but our eyes override it in favor of other colors. This is the way that we see a star's color. We're not actually seeing one color, but a combination of all these colors that the black body covers. So when you see a red star, you're actually seeing a combination of blues, green, yellow, and red. And then these are colors that we cannot see, and ultraviolet is also colors we cannot see. So the hotter a star gets, the more towards the blue it would be, until eventually it just gets a very dark blue. It will never be purple. And if any star's color is green or yellow, it would likely appear white, or it would lean towards whichever side is closer to blue or red. Humans are limited to only the part of the electromagnetic spectrum that they can see, and our brains choose to look for them in a specific order, meaning that a green, pink, or purple dominant star would likely appear blue, red, or simply white. But this does not always mean that's how they really look. Here's what I mean. There may be a few ways that we could see stars as other colors than normal. One way would be red shifting or blue shifting. Color shifting is a phenomenon where an object's color appears to change based on extreme levels of movement. This may theoretically result in the appearance of a green or purple star, but that would only be an illusion. So while it's an interesting thought, we can rule this one out. Another way would be binary stars lighting mixing to appear pink. Binary stars occur when two stars are orbiting around each other. They are extremely common in space and can sometimes be confused for a single star. If, for example, a white star and another dim red star eclipsed and appear to be one, they could look like a whole new shade of red, even pink. Again, this would only be a misinterpretation. So far, the only way a star would appear to be in any of these colors is through human error. But what if humans didn't need to make errors to see these colors of stars? What if we could see them naturally? The only real way we would ever see green, purple, or pink stars is if our vision worked differently, in a way where we were able to prioritize these colors over blue, red, and yellow.